Hello and welcome to this British Academy event. I'm Linda Geddes. I'm a science correspondent at The Guardian and the author of Chasing the Sun, which is all about how light affects our physical and mental health, including our sleep, which is precisely what we're going to be talking about this afternoon. Today's event forms part of the British Academy's Summer Showcase, a free festival of ideas for curious minds. The festival celebrates the best new research in history, psychology, sociology, and more, with online talks, discussions, and demonstrations, plus self-guided audio walks taking place throughout the week. You can find out more at britishacademy.ac.uk/summer showcase. This afternoon, I'm delighted to welcome Nayantara Santhi to our virtual stage. Nayantara is the Vice-Chancellor's Senior Research Fellow at Northumbria University, where she specialises in sleep research. And today, we're going to be discussing one of her key areas of work, which is the connection between light, circadian rhythms, sleep, and mental functions. We're going to be speaking in conversation for about 30 minutes before opening up to audience questions. And if you'd like to ask a question, please use the Q&A tab at the bottom of your screen. Now, I know Nayantara because a few years ago when I was researching my book, we worked together on an experiment looking at what would happen if I went cold turkey on light after sunset and tried to spend more of my daytimes outdoors. We can discuss this and other related research in a bit. But first of all, Nayantara, perhaps you could summarise for our audience just how light and circadian rhythms and sleep and mental functions are connected.
Sure. Hi, Linda. Nice to see you again after the previous project that we had, and welcome to the audience. So let's talk about the relationship between circadian rhythm, sleep, and light. To start with, timing and temporal rhythms are a fundamental part of biology, and they occur at many time scales, from milliseconds at the lower level to seasonality at the upper end. Of these, the 24-hour cycles, or circadian rhythms as we know them, are the most pervasive. And if you look at nature, really, you can observe them at the microscopic level, from bacteria to plants all the way to humans. So the question really is, how does the internal body of any of these organisms or the internal body of humans know what time is, how to time these events? And it turns out we have a biological clock in the brain, and it sets the time for the rest of the clocks in the body. Now, the strongest signal for the biological clock is light. And really, there is a direct pathway from the eye to the clock in the brain that transmits the light signal. And I think the way I think about circadian rhythms is like a grand symphony, if you will. The biological clock is the conductor, with light as one of the batons that the clock uses to orchestrate the timing of all the little clocks that we have in the various tissues and organs. And really, the symphony is a well-orchestrated song, if you will, and each of these little clocks and the organs march to their own tune. For example, some peak at night and go down during the day, while others peak during the day and go down during the night. And light is a very important thing. And this is one of the areas of research that are of great interest to me. And how does sleep really feature into this? Well, one of the most observable circadian rhythms is really sleep. And if you think about it, we are wired to sleep at the same time every day, which is night for us, and keep awake during the day. And this is what I'm particularly interested in.
Okay, and sleep aside, what other biological processes do these tiny clocks, these circadian rhythms control? I mean, just how important are they?
They control every physiological process in the body and every mental function, all the way to gene expression to hormonal rhythms. your temperature rhythms, your alertness, your mood, your social behavior. All of this is timed and rhythmic with the 24-hour cycle of the planet.
And what happens if those rhythms fall out of kilter with the time of day outdoors?
And isn't that something that we all have really experienced? Probably the most common experience is when you do transatlantic flights, you go across several time zones. You don't feel so good. You feel sleepy at the wrong time. Perhaps your stomach doesn't feel really good. You feel disoriented and tired. And that's really what happens when the circadian rhythms are out of kilter with your sleep-wake schedule. And on a more serious level, this is something that can happen with a lot of underlying pathological physiology and mental conditions. And this is a prime area of research that scientists are really beginning to focus on now.
Absolutely. And the Nobel Prize for Medicine went to the scientists who discovered the biological mechanisms of the clock a few years ago. But sleep is another massively growing area of research. Why do you think sleep has become such a hot topic in recent years?
Right. So one of the drivers of this, I think, is the digital revolution. For the first time in history, we have access to light, communication, and entertainment literally 24 hours of the day. We no longer have to shut down everything at dusk and go to sleep. While this has proved to have enormous advantages, it also has a downside to it. The light, as I explained before, is the strongest signal for the biological clock, which then sets the time for you to sleep. And light after dark really interferes with sleep. And I think people have begun to really acknowledge this, and there's a growing recognition of this. And this is one of the big drivers of the growing interest in sleep research. The other one, I think, is in the last decade or so, the enormous advances that have been made in brain research technology really allows us to look inside the sleeping brain, and the mechanisms and pathways underlying circadian rhythms and our sleep-wake cycle are beginning to be unraveled. And this is very exciting for a scientist. And I think these two drivers have really contributed to this enormous interest in sleep research.
Yeah, and I think there's this growing awareness really that sleep is not just something we it's not an optional extra. It's actually really fundamental to our mental and physical health. Can you tell us a bit more about why sleep matters? Why does it matter whether we get enough sleep at night?
Absolutely. So the way I think about it, we spend a third of our lives in sleep, and we now know that we don't completely shut down either mentally or physically. The body and the brain is active during sleep as it is during wake, just in a different way. More critically, even though we haven't uncovered all the functions of sleep, it is quite clear that sleep contributes a huge recovery function. And if you interfere with that, then you interfere with the recovery process. And you also interfere with a lot of the other processes that happen during sleep. And that has knock-on effects. It affects your mental functions, it impairs your performance, and it also affects everything from your cardiovascular system to your metabolism to your gastrointestinal system down to the molecular level. And that's why sleep is not an option, it is a necessity. It's the reason why it is wired into us to spend a third of our life sleeping, or approximately that much.
Yeah. And as you just alluded to, our relationship with light has dramatically changed really in the last 140 years since the invention of the electric light bulb. So, today we spend lots of us live in light polluted cities. We spend most of our daytime indoors. And we spend our evenings often connected to TV screens or looking at our smartphones. And there's this kind of growing feeling that light at night is bad for us. But is it as clear cut as those kind of media headlines about you must not look at your smartphone screen at night? Is it as clear cut as newspapers would have us believe?
Well, yes and no. So I'm going to illustrate three things that happen when you use light at night, and even if it is just light from your cell phones or digital devices. Looking at these things can be arousing because it's a lot of information, perhaps exciting information, perhaps not so good information. So your brain is wired before you go to sleep. But beyond that, something else that light does is it has a great effect on your sleepiness and alertness rhythms. It increases your alertness levels and it suppresses your sleepiness. And sleepiness is an important behavioral signal for your brain to say, okay, now I need to start preparing for sleep. And another important thing at a physiological level is light suppresses melatonin. And melatonin is your hormone of darkness. It starts to increase after dusk. And once again, that's a signal for your brain and the sleep systems in your brain to then say, oh, it's time to go to sleep. And you interfere with this signal, you interfere with the timing of sleep. And really what light in the evening, the way we use it does is it interferes with all of this. It delays your sleep onset. And unfortunately, for most of us, delaying sleep doesn't mean we can automatically delay wake time. We have to, for social reasons, wake up at the same time every day. So you end up with this sort of shortened sleep and perhaps a buildup of sleep loss over time. And that's the reason why light has a negative impact. But at the same time, light is not all bad. It depends on the context. There are good aspects to using light as well. You can use it quite judiciously to help you. In the extreme northern latitudes, which I think in the UK we might experience, you have the seasonal affective disorder, or your mood is a bit low during the long dark months, and light has been used as an effective treatment aid for seasonal affective disorders for a long time now. You can also use light to increase alertness, perhaps to help you adapt better to certain shift schedules. So it really depends on the context and how you use it. But in the evening, I think one should think twice about the kind of light you expose to.
Yeah, I was really struck when I was researching Chasing the Sun. I went and spent a long weekend with an Amish community in the US, and they are not connected to the electric grid. So, when the sun sets, all they really have, and they live in fairly big houses, they have big families, and all they really have at night is this one large gas light, which they wheel around the downstairs of their house. If they go to the bathroom, they take a torch with them, or like more traditionally, an oil lamp. So the kind of light they're exposed to in the evening is much more akin to what we might have been experiencing, hundreds of years ago, when all we really had were lamps and candles, if people could afford them. And one thing you notice over there with the Amish is that they are, you talked about sleep timing, their kind of normal bedtime is more like 9 p.m. That's when they tend to go to bed, and studies have looked at this as well. And then you look at the time they wake up in the morning, and the whole of Amish society is kind of getting going at about 5 a.m. I was there on Memorial Day weekend, which is a kind of like a bank holiday in May, and they had all these yard sales, and everyone was leaving the house at, we were literally going out at 5 a.m. and we arriving at these yard sales about 5:30, and people were stoking up their barbecues, laying out their stalls. So this I think it's really, it has this profound effect. But daylight is also important, right? So tell us a bit more about your research in this area.
So I remember the work you did with us. I think exposure to daylight is something that is underappreciated and not talked about a lot. All of the media focuses on light in the evening, and indeed, we now know quite a bit about it, and there's a lot of awareness about what it can do. But equally important is exposure to daylight. So something really simple. Most of us have a circadian cycle that's a little bit longer or lesser than 24 hours. and our clock constantly has to adjust to keep it to 24 hours, to keep it entrained. And this really happens with exposure to daylight in the morning, like in the early morning hours. It allows your clock to kind of wiggle it a little bit so that it remains entrained to the light-dark cycle. Beyond that, exposure to daylight overall is very important for our circadian system to maintain its timing and to keep the rhythms going. And the reason for this is our indoor light is nowhere near as bright as the daylight outside. Even on a cloudy day, the intensity of light outside is far, far greater than what it is inside. So exposure to daylight is as important as not having too much light at night. And maybe a lot of us have been able to do this during the pandemic. Just going out for a walk in the afternoon is something that is very, very helpful.
Yeah, so to give a kind of an idea of the scale of the magnitude of the difference, like the kind of, the intensity or brightness of light is measured in this unit called lux, and in a kind of standard office it's maybe 250 lux indoors. On a bright sunny day like it is today, it might be 100,000 lux outdoors. It's massively different.
Absolutely.
And what about in summer? So what about seasonal differences in light intensity, and how the long summer days impact our sleep and alertness?
Sure. I think if you talk to people who live in the extreme latitudes, they're always going to complain about their sleep being a bit disturbed during the long summer days. I can attest to that. I can tell during the long summer days, I don't sleep as well. And that's because you have a lot of light exposure, and actually bright light well into the hours after dusk. So I live in Newcastle, and currently it's quite brightly lit outside till about 9:30 in the evening, and it doesn't really get completely dark until 10:30 or so, and it gets light out at 4 in the morning. So unless you protect your bedroom window from this, the bright light really affects your sleep. You go to sleep later, you wake up earlier, and then you have the problem of sleep loss, sort of this buildup of sleep debt.
Yeah, so actually we've had a couple of questions in. One from Jay Marsh, who says, how does the evidence for how seasonal changes relate to sleep quality and quantity, which you've kind of talked about? And you mentioned seasonal affective disorder links. I mean, how real is seasonal affective disorder?
Oh, seasonal affective disorders are very real. Now, I myself haven't personally done research in that area, but this has a long tradition of decades of research. It's a real phenomena. It happens during the long, dark winter days when your mood is a bit suppressed, and some of it can be serious enough that it kind of affects your day-to-day functioning. So there's a lot of scientific evidence on seasonal affective disorders. And it's a very real phenomena. And certainly light helps it a lot. You can actually just buy one of these sort of bright light lamps that are sold commercially. And in the winter, if you have it on in your room, you will just find a subtle change in your mood. It just helps you feel a bit brighter. It lifts your mood. It makes you feel more alert.
I was really struck actually when I came down, when you were previously working at the University of Surrey in Guildford. I came down and I noticed that some of the researchers had a sad light on their desk, and they were using it not in the middle of winter, but they were just using it to kind of perk themselves up during the daytime.
Absolutely, yes. I mean, we now know that light not only helps you with vision, but it has these so-called non-visual effects. And there is a non-visual effect on alertness and mood. Now, scientists haven't worked out the pathways completely yet. But certainly, for those of us who live in sort of geographical regions which tends to have a lot of dark gray days, you do know a sunny day immediately uplifts you. You feel more energetic, you feel kind of lighter, you feel more alert. So there's definitely a very strong effect of light on alertness and mood. It's documented. it would be nice. We just have to work out the exact mechanisms and pathway.
And your research has, has real world impact and value for health professionals and I guess the wider community. How can these kind of findings about light and sleep be used and kind of put to practical use?
Sure. So let me start with light. So we talked about exposure to outdoor light during the daytime and reduced exposure to light, indoor light in the evening. Now, I don't think we could ever go back to a time, unless you were living in an Amish community, of not having light in the evening. It certainly helps us to see. But what we can pay attention to, for example, with indoor lighting for the evening hours, is the type of light that you have. Now, I've done a lot of work on looking at how the intensity of light, timing of light, and the spectral or wavelength composition of light affects your circadian timing and sleep. So you can actually manipulate these physical characteristics in a way that it doesn't affect your vision in the evening, but perhaps it has less of a negative impact on sleep and circadian system. For example, reducing the amount of blue wavelength light is helpful in the evening. On the other hand, the same research that I've done also shows that if you are a night shift worker and you're in an office environment, having an extra bit of blue wavelength light in an office environment is helpful because it keeps you alert. It enhances your mood as well. On a slightly more complicated level, you can use light exposure to actually shift the timing of your circadian clock so that it becomes more adaptable to a night shift. That can be done as well. And you don't even have to use light exposure. You can schedule your sleep appropriately to provide you with the correct light exposure to help your circadian system to adapt. That's a very easy thing to do, because when you sleep at a certain regular time every day, you are automatically controlling the timing of your light exposure. So that's one of the ways in which the work that I do helps and can be applied.
What can be done to help night shift workers then? Because, it's quite difficult to control your light exposure if you're having to go into a hospital or a power station at night when the lights are switched on.
Yeah. It probably would help if people working at night could have some of these commercial devices on their table. They're just small devices that are available. Of course, the ideal would be to change the light setting in the work environment. I'm not so sure how feasible it is in a hospital, but that's one of the things that night shift workers could do, hospital workers could do. But something that they could do, and this was one of the earliest studies that I conducted when I started my research in this area, it's really the timing of your sleep schedule when you're on a night shift. So think about it. What does a night shift worker normally do? They finish the night shift at 7 a.m. in the morning. They probably come back home, fall asleep immediately because they're really tired and sleepy. They can't sleep for more than 2-3 hours because your body is not designed to sleep during the day. They wake up. There are social constraints also which prevent them from getting a long period of sleep during the day. So they've slept for about 2-3 hours, maybe 4 hours tops. And then they wake up, maybe noon, 1 p.m., and then they are awake till they start their night shift. And by the time they start the night shift, they are really sleepy. But this sleep schedule also varies. It changes with the day. What my research showed was we compared two different sleep schedules. One is this morning sleep schedule. The other one, we delayed sleep to about 2 p.m. in the evening, in the afternoon, and got them to wake up a little later. And that seemed to help. So delaying your sleep and waking up later means you are being awake for less time before you start your shift. And that has this follow-on effect. But the other thing to pay attention to is on a night shift, you need to do this in a disciplined, systematic way. You do need to maintain that timing of sleep because it controls your light exposure. I understand all of this is easier said than done, but that's one of the things that could be useful. The other detrimental thing about shift work, and this is a larger debate, is a lot of people have very fast rotating shifts. So they do a few day shifts, and then they probably have a free day, and then they rotate into a night shift, and they do this consistently. And the problem is your system cannot adapt. So it's eternally in this misaligned state. So that's a larger debate that society might want to engage in.
Yeah, okay. And we've talked a lot about light, but of course, light isn't the only thing that affects people's sleep. And just before we go over to audience questions, I know that over the past year during the pandemic, you've been looking at disturbed sleep patterns as a result of, kind of worry and anxiety. Can you tell us a bit more about the impact the pandemic has been having on people's sleep cycles?
Right. It's actually a very interesting sort of paradoxical finding. So on the one hand, because for a lot of people, the commute has been completely eliminated during the pandemic. People work at home. This means people have a lot more time during the day to schedule their sleep. And it turns out that there are studies which have shown that people have been sleeping longer. But at the same time, the sleep quality has not been that good. And that is not surprising. You have the anxiety and stress of the pandemic, which impacts your sleep. So that's one of the things that has been happening. And it's very interesting. This, of course, has interacted with age. So younger people seem to have a lot more problems with sleep, or they sleep longer, but not very well. They seem to have been impacted a little bit more than older people. So there are a lot of these differences. And I recently read a paper where they said sort of people's timing, almost chronotype, has shifted a little bit. They've been going to sleep a bit later, and that is, again, not surprising relative to what they were doing before. And of course, you can probably wake up a little later too, because you no longer have the commute. But all in all, I think the pandemic has produced a lot of sleep problems and a lot of sleep complaints, and I think people's dreams have also changed. There are more reports of people experiencing nightmares. Again, not surprising. And the one last thing, the social isolation and withdrawal that we are all forced into has also affected sleep. And it kind of works both ways. If you're socially isolated, you tend to have sleep problems. And if you have sleep problems, it contributes to social isolation as well.
Yeah, and actually that's going to be the topic of your next lot of research. So why don't you just, before we go to questions, just tell us about what's next on the horizon for you work-wise?
So 3 areas of expansion is what I'm going to be doing in my lab. So we talked a lot about the role of light and sleep, because light is the strongest signal. But something else that is also important for sleep is the environmental temperature. Let's not forget that we are all wired to sleep during the coolest part of the day. Also, when it's very warm or hot at night, it's a bit harder to sleep, which might be the case for many people in the UK today. It's a fairly warm day, so people are going to find it hard to sleep. And there is quite a lot of research showing that it's helpful if you sort of get yourself into what they call the thermoneutral or comfortable temperature zone for yourself before you go to sleep, neither too hot nor too cold. But we don't really know the mechanisms underlying how temperature influences sleep, simply because temperature doesn't have a direct pathway to the clock or sleep systems as light does. So this is something that I would like to look into. And there is, of course, the larger question with the climate change and rising temperature in many places. What is that going to do to your sleep? And the other area of research, as you mentioned, and this is vastly under research, is the role of sleep in social cognition. How does sleep affect your social behavior? And I have funding from the British Academy to look into that. And the other area that I'm really interested in is sort of the continuum of consciousness from wake to sleep, particularly the in-between area between wake and sleep. And I've done a little bit of work on that. Immediately after you wake up, it takes a while for your brain to reach full alertness. And that's called sleep inertia. That's the state. But you have all these other interesting states of mind, like mindfulness and meditation. And there's a lot of news items, and you read everywhere about practicing mindfulness and meditation so you sleep better. And in my opinion, part of meditation and mindfulness is to increase your awareness and focus your mind. So the question is, how does that really figure into helping you sleep better? So those are some of the things that I will look into.
Okay, great. Well, let's take some more questions from
Sure.
our audience. Jill asks, does reading a book by a sidelight have the same detrimental effect as phone lights? And I know earlier you were mentioning blue wavelength light, so maybe let's unpick the different types of light that you can be exposed to at night and how those things might affect your sleep.
Yeah. In general, I think reading a book can, for some people, relax you. And, having one of these reading lamps, if it's low intensity and you can read by it, might not be as detrimental to sleep as phone and digital media. And largely because phones and digital media do have a lot of blue content in them. And you could argue that, well, these days phones have the sort of blue light filter. But again, I think the other problem with phones and digital media is it is arousing. You're going to see exciting information or something that sets your brain off. And I think it's the interaction between light and setting your brain off that becomes detrimental to sleep.
Yeah, and we should say when we're talking about blue light, we're not talking about light that necessarily looks blue. So
Correct.
For instance, those the kind of really bright white the kind of standard LED fittings, especially that you get in kitchens and bathroom lights,
yes,
are one of the problems. What do you think about circadian lighting, or what's sometimes called human-centric lighting? This, you can get these kind of smart systems now which change the color and intensity of the light in your home as you kind of move into night. Do you think that's a good thing?
I absolutely do. And in fact, we did some research on this when I was at the University of Surrey a few years ago. So we manipulated both the intensity and spectral composition of light, and we had several different wavelengths of light, if you will. So we went from yellow light, which had absolutely no blue content, all the way to enriched blue light. And we also manipulated the intensity. Now, it turned out that 150 lux of blue enriched light completely suppressed melatonin in the evening, but 150 or 200 lux of what I'm going to call yellow light, which had no blue content, was less suppressive, had a less suppressive effect on melatonin. So I absolutely think that is moving in the right direction. And this goes back to something that I said earlier. We're not going to be able to go back to candlelight for a number of different reasons. We do need a certain intensity of light to be able to continue with our visual activities at night. So a circadian light, I think, is moving in the right direction, certainly. The important thing, I really think, is digital media. And to answer the question, to add to the answer I gave to the question on the book, the problem with digital media is it is digital media. It has sound, it has light. It engages your senses. You're not sitting quietly and reading a book. So that has an alerting and arousal effect on its own. And that's why digital media tends to have a more negative impact on our sleep and circadian rhythms.
Yeah, I was inwardly laughing when you talked about the problem with candles. So when I was doing my experiment where I got rid of artificial light,
Right.
I was living by candlelight, and cooking by candlelight is not to be recommended.
Oh.
So I ended up putting some of those kind of smart light bulbs in the lights over our kitchen island, just so I could cook without cutting my fingers off or food poisoning guests. We've had a few questions in about kind of seasonality. So Annie asks, do the times the Amish go to bed and rise vary according to the time of year? I can say that the answer to that is yes, but maybe so that they do tend to go to bed a little earlier and get a little more sleep in the winter time. But maybe you can comment on that, because I know you've done some research in college students.
There certainly is a seasonality effect. So it is quite clear, if you live in the extreme latitudes where you have these big differences in day length, your sleep is affected in the summer. You sleep a little less in the summer, you sleep longer in the winter. And again, besides light, temperature, the environmental temperature also plays a role. And this is something that has not been researched a lot. It is much colder in the summer. Colder in the winter, and it's a bit warmer in the summer. So how the interaction between the light-dark cycle and the environmental temperature plays a role is an interesting question. But indeed, there are absolute differences between sleeping in the summer and winter. If you have long, dark days, you probably go to bed a little bit later. Everything is shifted. And you may wake up a little later, but not a lot, because it also gets light out earlier. Whereas in the winter, you tend to stay in bed a little longer. So yeah, seasonality makes a difference.
And I think there were those camping studies by Kenneth Wright at the University of Colorado, where he actually sent people camping in the summertime and the wintertime. And he found that in the wintertime, people were just going to bed earlier, probably because it was colder. And there was less to do. And yeah, okay, you can sit up and eat marshmallows by the fire, but when it gets to dark at 4 p.m, there's a limited amount of time you want to be doing that. Okay, and then David asks again about the Amish, saying he finds it interesting that in Finland they have one of the world's highest rates of seasonal affective disorder, whereas Norwegians who have similar winter light hardly suffer from it. So is seasonal affective disorder physiological or psychological, or do you think it's a bit of both?
I think it's a bit of both. I really do think it's a bit of both. I'm sure people in Norway also have seasonal affective disorders, but it would be interesting to know, maybe they engage in certain behaviors that prevents it from having this widespread occurrence in the population. I don't know if they have different types of lighting at home or they pay attention to it. It also would depend on the geographical location. Probably in the really far north of Norway, you might tend to have more seasonal affective disorders, or people use more light over there. And there are physiological differences. There might be cultural differences as well.
Yeah. So actually, when I was researching Chasing the Sun, I went up to Tromsø in northern Norway, right up in the Arctic Circle. And I went during the dark period, which is when the sun doesn't actually come above the horizon for about 6 weeks in December and January. And actually, Tromsø bucks this trend for seasonal affective disorder. They have quite low rates. But if you interview people there, they say that when people first move up there, they get sad really badly, but over time they adapt. And there's this kind of cultural thing up there where they see the dark time as this special time, and they embrace it. They call it kos, or kos, short for koslig, which is where all about making your home cozy. It's a bit like, I never know how to say the huggy, the thing in Sweden or Denmark, but this idea that you can make your home cozy and you can embrace it, and you can have soft lighting and candlelight, and winter is a time for kind of cozying up with your family and friends, whereas summer is a time for kind of going out and hiking at midnight and so on. which I think.
Exactly. So in the modern world today, we talk about light regimes and light therapies for seasonal affective disorders. But culturally, in a lot of these places, they have other ways of approaching it and managing it. And I'm sure a lot of cultural differences contributes to the prevalence of seasonal affective disorders. And perhaps over time, when you live in a place, you may get used to it. And again, like the people in Norway told you, when you first move up there, it is a shock to your system.
Yeah, okay. And then we've got a couple more questions just before we wrap up. About kind of chronotype and about how your mood and cognition varies over the time of day. So Emma asks, are there people who have their sleep physiologically capped? So, that they only ever get 7 hours of sleep a night. I suppose she's talking there about, how come some people seem to be able to get away with, only having 5 hours sleep, and then others like me need like a good 8 or 9 hours, otherwise they feel ghastly.
Yeah, so this touches upon the short and long sleepers, which actually is still a debated issue in the field. Now, I think about 7 or 8 years ago, there was an interesting paper in Science that looked at the genetic predisposition to being short sleepers. So there is a genetic polymorphism that's been identified. And I actually have a friend who has also done a lot of work on short and long sleepers. So indeed, there are some people who are naturally short sleepers and some people who are naturally long sleepers. But again, as with any extreme, they are few and far between. Unlike chronotype, which is an identified trait and also has a genetic basis to it, it's been quite difficult to nail down the biology of short sleepers and long sleepers. Now, there are people who are short sleepers and long sleepers, but if you study them in the lab, so if you put short sleepers and long sleepers on an extended wakefulness schedule or a sleep deprivation schedule, short sleepers tend to crash faster. So while they function perfectly fine on short sleep, they are on such a tight leash that if you push them a little bit more, they don't hold up. They're not as resilient as long sleepers are. But then again, the whole thing also interacts with chronotype.
Yeah. Okay, fine. And then just a final question from Jay Marsh again, who says, I've heard learning a memory is better first thing in the morning and last thing at night. Does that have anything to do with sleep? I mean, tell us a bit about these kind of cognitive differences over the day. How does people's learning a memory vary by time of day?
So if you look at somebody's sort of general cognitive functions over the 24-hour period, many of them, like attention, alertness, and memory, varies with time of day. And it is interesting. I don't know if many people in the audience are aware of this, but the time of day when your brain is most alert is in the evening hours, and it's called the wake maintenance zone, which is the hardest time to fall asleep. And the time of day when your brain is least alert is sort of in the early morning hours, roughly say about 2 to 4 a.m. if you go to sleep at night and keep awake in the morning. And that's called the sleep promotion zone. It's when you are the sleepiest. And you can see a nice rhythm to it. However, this is not true of all cognitive domains. Some of them are more, show a bigger and stronger rhythm than others. There are also a lot of individual differences in this as well. And lately, there is some new research coming out, and this is mostly, I think, preclinical research, which shows that cognitive functions like anger and hostility also show a circadian pattern to it. And there are underlying mechanisms that are being investigated. It's also one of the reasons why I'm interested in sleep, circadian rhythms, and social cognition. But that's basically how it goes. And I know I don't have a simple, straight answer. I think some functions like attention and alertness show a very nice rhythm. Others show less of a rhythm, but this varies between older and younger adults.
Yeah, and between teenagers as well, right? So
Sure.
you know, I think there's been studies suggesting that certain kind of learning and alertness peak later for teenagers than they do for older adults.
Absolutely. And this is the circadian rhythm part of it. In terms of sleep, I think now it's well established that, you know, the two broad stages of sleep is sort of the deep sleep and REM sleep have an impact on different types of memory. REM sleep is more involved in consolidation of emotional memory, whereas deep sleep is more involved in the consolidation of non-emotional memory. So certainly, if you are a college student doing an exam, it might be better for you to get a good night's sleep rather than stay up all night.
Okay, fantastic. Well, time is getting on, so thank you very much to Nayantara Santhi for such an insightful discussion. The British Academy's Summer Showcase runs until the 19th of June, and you can find out more on the British Academy's website and social media channels. Thanks once again to Nayantara for joining us today, and to our audience for their excellent questions. Thank you very much.
Thank you.